Hey there! Alright, so we're still talking about metaballs. In our last video, we attached event handlers to the metaballs. They can detect the mouse motion event, they can detect the left click event, and the mouse wheel. You can see we can drag and move them around, we can grow and shrink them. Right click will delete them, and then left clicking on an empty space will add a new metaball to the metaball blob collection. What I'm going to be showing you today is how to fill in this area. And here we go. So, I'm going to first load up the branch. I'm going to be talking through two branches today. The first one is the performance branch. And most of this was about things like, let's see if we go to blob collection. You can see in render segment, change this so that it's only going to draw a line if the from and to coordinates are not the same. Right now, because the pixel size is so large, then we have the grid resolution set to 1, so every single pixel is being checked. And if the from and to of these line segments is the same, we don't need a line, we just need to draw a pixel. And I'm using a lot of these parallel for loops. It's just a cheap way of making everything happen all at once. Which is fine as long as we have a single blob collection. It's like a later video I'll show you what happens if you have multiple blob collections all rendering simultaneously. It's going to be very exciting. If you run the performance branch, oh yeah, stop the motion also. But you can drag them around, and it's pretty smooth motion. I love how fluid everything is, the way the blobs just kind of merge together as they get closer. Also, if you have a metaball collection of 1, what you have is a basic circle renderer, which is a useful thing to remember. Right now, if you go into the toolkit itself, RetroTK, GFX, and we have a rendering context. There's a render circle method, which uses the midpoint circle algorithm, which is just a way of, it's almost like Bresenham's line algorithm, the way it kind of steps around the edge of the circle. Line drawing algorithm is actually like Bresenham's algorithm. You can see that here if you're interested. But there's a pile of functions here for rendering a circle. We got a function here for rendering the outline of a circle. And we can also render a filled circle. Where is that? Here. The algorithm is basically the same as drawing a circle, except the difference is, it's like, do a comparative analysis here. So here, basically rendering the points around a circle. Trying to figure out the best way to describe this, trying to decide how much detail to go into. Basically, this steps over every single point in the circle area. It's been a while since I wrote this. No, this one is actually a much more straightforward algorithm than the midpoint circle algorithm, because this is just calculating distance from the center and then drawing all the points in that range. So I guess it's not super efficient. Of course, you could also use the flood fill algorithm here, in which case you would draw the circle outline and then give it a point inside the circle and a color. And what this does is it keeps a stack of points, and it kind of works its way outward from the initial point, checking all the surrounding points to see if they match the source color, and if they do, replace it with the destination color, and it kind of keeps going until it hits the destination color, which would be the circle outline. And that is another way that we could fill the circle. Let's run some examples. If we go... Let's see. Don't need rendering context. We need main state. We're going to turn this off for a bit. Archie, render circle. Got the position. Give it a radius of 64. Outline it in yellow. And now if we run this, what we have is a yellow circle. Now if we wanted to fill that in, why do I have fill versus flood? Oh yeah, fill. The fill function fills the entire screen. We can flood fill if we give it that same position for the center of our circle. And then... Oh, why is that fussing? Flood fill, flood fill. Did I not include a version of flood fill that takes a radial color? Fix that right quick. There we go. And then okay, so now we can fill with an actual color object. Oh, we have to add that to the interface also. Grab that description. There. So, we can flood fill the circle. There you go. Flood fill with red. And I misspoke earlier. The flood fill algorithm will continue until it hits something that doesn't match the source color. So it'll hit all the black area. Another way we could do this render filled circle. Radius 64. There, I'm going to render a red circle. There you go, one red circle. Very mathematically accurate, at least to floating point number precision. If you still wanted the outline, we can grab that, stick it down here. And you see the midpoint circle algorithm lobs off that tiny dot that was at the end. I'll remove it. And there you go. So, now there's another way we could do this, and that is Render ordered dithered circle. Bit more of a mouthful. Same radius. We are going to still use a red. And it has a fall off start, which we're going to leave as 0.6, and a secondary color. Let's use yellow for that. And let's see. What this is doing we have this thing, this Bayer matrix. I forget the history here, but I believe the discoverer of this matrix, I believe his last name was Bayer. That's all I got there. But there's a lot of math here. We're looping over every pixel within the bounds that could be within the bounds of this circle, which is what's going on here, based off the center of the circle and the radius. And then we have an inner radius and an outer radius. If we go back to our example, it's basically based off of percentages. We got the red going out for basically 60% of the circle's total radius. And after that, it begins this fall-off math. If we're outside the circle, then we're not drawing anything. If we're inside the inner radius, we're just using the primary color. But for the in-between, we're kind of blending our two colors together as much as you can with an indexed palette. So, a normalized distance, and then we have to, let's see, dx and dy, where were those? Delta x and delta y, use that to get the index into the Bayer matrix. And then, if we're inside of the threshold value, we use the primary color. Otherwise, if the secondary color is defined, we'll use the secondary color. Now, the neat thing about this, let's make our circle bigger. New radio color. Red, green, blue. Red, green, blue, going from light red on the outside to dark red in the middle. And then, what was that parameter called again? We have the fall off. We are going to attach that to a keyboard event. So we can bump the fall off up and down to see how it affects the rendering. There you go. And then increasing the fall off until you can keep increasing it until it gets to 1, and then basically you have a filled circle like the previous circle filling algorithm. And if we go the other way, decreasing the fall off, it's almost like dimming the lights. And this is kind of a neat way of blending two colors together when you have a limited color range. can also use this effect if you like actually as a light, if you wanted to make it look like a light was growing brighter or dimmer. And that raises the question of what it would look like if we attach this to the timer. Here, let's do this. This will be fun. Just fall off start. Sign, game time, total time. Total seconds. And then we add 1. Sine wave goes from -1 to 1, so we add 1 to bring it to the range of 0 to 2. And then we divide by 2 to bring it back down to the range of 0 to 1. And we'll make that our new fall-off value. And see what effect that has. That's kind of fun. So I'd like to use a version of this algorithm to color the inside of our metaballs. I'm rather enjoying watching this. Anyway, stopping that, we're going to switch branches again to the flood fill branch. It's not really a flood fill. Don't need rendering context. Going to look at blob renderer, going to blob collection, and there's a new thing. This is broken up a little bit differently. Still calculating the samples. We're rendering the outline here like we were before, but there's another intermediary step here for rendering the Bayer field. And you can see we have that same matrix loaded up as a constant, sort of a constant. Static read only. It's like a, for all practical purposes, it's a constant, except that it's technically not. Rendering the Bayer field, though. Let's take a closer look. Sample we're treating as intensity value at that location. And anything with an intensity less than 1 we're considering to be outside our fill range. Okay. And basically, the subtracting one, basically, if it's less than 1, we don't care about that value. It's outside of our metaball area. So we normalize that. Now the lowest value is still 0. Clamping that from 0 to 1. We need intensity from 0 to 1. The same thing, we're calculating the x and y into the Bayer matrix the same as we were before, getting that threshold value. And there's no, we're dealing with a secondary color a little bit different from before. If the intensity is greater than the threshold, just set the pixel color. Let me load up the rendering context again so you can see the difference. It's like the normalized distance. It's like color, that's for... Basically, this math chooses whether we're going to draw with the primary or the secondary colors. when we're doing the dithering operation. But this part is actually reversed, and I had to do that to get the colors to render in the correct order. Actually, I had to play with this algorithm a bit to get it to perform the way I want it to. Let me show you what it looks like. That'd be the easiest place to start. Alright, so we're rendering this field. And it's using a similar kind, you can see a similar kind of dithering operation going on as before between the primary and secondary colors. And if we kept this the way it was previously, I guess it doesn't look that bad, but it's like it just doesn't look quite right. The primary color is practically missing. You can see it kind of poking around the edges right there. Through this some more. At one point I thought applying that sine function to the fall off looked better, but I don't know. Wasn't really worth the cost of another math operation. The fall off value is basically not here anymore. Like it was a constant value over here, fall off start. Reminder, that one is used to calculate the inner radius where we're just using the primary color. And we're not bothering with that step at all here. At this point, let's see, give me a second, I'll draw a picture for you. You might be able to begin to see how we could use these metaballs to make little creatures. Find some way of connecting the balls with some kind of skeleton framework so that they moved in a reasonable manner relative to each other. If I had a way of either having multiple blob collections to fighting a single critter, or a way of applying multiple colors over the range of a collection, which I haven't quite figured out yet, but I feel like there's bound to be a way to do it. We're already blending between two colors here, so blending in between more colors shouldn't be that challenging. We already have the dithering operation. But that is it for how we're going to handle filling in these blobs. And the next video is going to be, we're going to try to turn this into some kind of critter that can move around the screen, just to see what it's like. So stay tuned, and should be hearing from me again soon.